Looks like there's a syncing issue. Well, while those are coming up, we're a company that likes to be able to create the opportunities for people to connect with each other. And connection can be the absolute mundane, it can be the absolute profound. It's the daily experiences that people have in their lives. Thank you. And so one of the first things is about how to share experience. So about 20 years ago, maybe less than that, in the developed world, people used to communicate by text and voice. And if someone had an experience that they wanted to share with somebody, they would just write it in text. And here's an example. You would not believe the acrobats I am watching right now at the circus. You might call somebody, you might text that, and that would communicate the emotion, the whole experience of what that moment was like for you. That's a 2G network. As you go to 3G networks, you can start to add photographs to explain that experience. With LTE, you can start to show video. You can do it live. You can pre-record it, send it over YouTube, things like that. You start to get more of an enriched experience to get a stronger feeling of being there. And that's one of our aims around what connectivity means and why we care about the progression of networks around the world. Finally, we're hoping that ultimately this leads to concepts of virtual and augmented reality, where rather than showing a video from a particular perspective, you can have any perspective. You can feel that space and time that were once separate are now able to be traversed very easily. You can go to any place or any time. That's why we care about networks getting better and better over time, because each stage requires more and more connectivity. But there's another aspect of why we care about this, which is completely orthogonal, which is around creating community. We really deeply care about community existing everywhere, and that can be in cities, in developed markets, it can be in rural communities of 400 people in an emerging market. Each one of those communities can be focused on employment, health, education, entertainment, financial and government services and applications. These are just a few, but ultimately we care about every community around the world being connected because we think this is the best and most scalable way for those kinds of experiences to be shared. So this is a little cartoon map. What we focus on are a range of technologies and business models for thinking about how connectivity can happen. And what it takes to connect people in cities is very different from trying to connect people in rural communities. And I'll try to get into that a little bit, but we believe that there is no silver bullet technology that would exist to connect everybody in the world. You have to look at the specific use case, the specific demographics, not an excruciating resolution. There may be 5 or 10 different technologies or business models that are required, but we do think there is more than one. And I'm not going to get into all of those today, but that's just one of the things that's sort of an aspect of our philosophy. But what I would like to get into is some of the data that goes behind some of the work that we do. So one of the, I think the real interesting insights, at least for me, is be able to see a worldwide network of 2 billion people active on a monthly basis. So this reflects our network. This is 2 billion monthly active people from the perspective of telecommunications. So the yellow parts that you can see, for example, the United States, parts of Europe, South Korea and Japan, Australia, those represent LTE networks. Peak capacities range from 100 megabits to hopefully soon a gigabit of speeds. And then at the bottom you see 2G connectivity. And large parts of the world, southern parts of the world, are still very much 2G and 3G connections. There's roughly 25 years of span of technology development between 2G and 4G, and roughly, in terms of peak data rates, 1,000 times a speed difference between the most connected users and the least connected users. So while we focus on the unconnected to the connected populations, we still want to be cognizant of the fact that 3 orders of magnitude of speed difference can exist between somebody in the United States and somebody in India. But let's pay attention to India for a second. This map was actually generated in June of 2016. And I would like you to pay attention to India because over a 9-month period, subsequent to when this image was generated, something pretty miraculous happened. To me, an example of a market success. So just watch India, and I'm going to switch to what happened in March of 2017, of this year. It switched. It went completely 4G in the matter of 9 months, based on the entry of a new competitor in the market named Reliance Jio. And they have connected over 100 million people in a matter of months, providing affordable LTE access to the entire country. So I think this is, to me, an example of really positive, rapid change. Let's take away the specifics of who was involved and what they did and things like that, but just to take away the example that rapid change can happen if there's determination to get it done. I think an example, a counterpoint, are perhaps market failures. There's been conversations around, public market failures, and I'd like to point out private failures as well. This question around rural access, if we look at sub-Saharan Africa, the cost of backhaul access is one of the primary drivers for why rural access is not sustainable for private enterprises in sub-Saharan Africa. In the United States and California, I can get a gigabit of access to my home. I can routinely get a peak capacity of a gigabit, and it costs me $40 per month to do so. Now, this isn't quite apples to apples, but a gigabit of access anywhere in sub-Saharan Africa costs anywhere today between $500,000 and $2.5 million. That is an enormous gap that exists. That is not driven by any regulatory environment. That is just the state of competition today. I'm going to switch gears and talk about a question that we wanted to answer at a fundamental level, which is, where are people located? We wanted to understand from our connectivity data sets, could we look at a difference map between where people are located to understand where unconnected people were? And so Columbia University, Jeff Sachs is here. The Earth Institute has created these wonderful maps worldwide, and there's a database called Gridded Population of the World. They're at version 4, and in some cases the resolution of these census maps goes to 1 square kilometer, where in each one of those pixels at 1 kilometer around the globe, you can find out what population density is. And so we were really interested in this as a perspective to understand, could you do network planning? Could you understand where resources are? Could we think about what the cost of connectivity would be for the unconnected people of the world? And this is an example in Naivasha, Kenya, and the data from CSIN at Columbia is on the right. Those are 1 kilometer square pixels. So from a network planning perspective, if you wanted to think about what is the cost of connectivity to connect this community, if you wanted to do it via means other than satellite, it's very, very hard to predict. If you look at the image on the left, which is a satellite image, your brain is able to parse and see that there's human development there at much, much higher resolution than the image on the right. And so we asked ourselves this natural question was, could we train computers using machine learning to identify human artifacts in that picture to be able to understand population density at much, much higher resolution than that is done on the image on the right. So we actually collaborated with Columbia University on this because they have these global census databases. This is a collaboration with the World Bank and local governments to see if we could combine the best of machine learning of images on the left with the census databases on the right to get much better resolution, to be able to understand some of the sort of systematic problems of thinking about what it would take to do connectivity. And so this is an example from the World Bank, their database on census information called WorldPop. And then this is what we were able to obtain in collaboration together. So the resolution went from 1 kilometer pixels to roughly 10 meter pixels. So in aerial resolution, it improved by a factor of 100,000. And because we have a lot of compute infrastructure in our data centers, we're able to process 15.6 billion images worldwide, and we've now released publicly with Columbia in partnership and the World Bank 23 countries at effectively sort of unprecedented resolution. And it's been really pleasing for us to get emails from the Red Cross and UNICEF and other aid organizations saying, thank you very much for providing these databases, because now we can find communities that we didn't even know existed, and think about what does aid, what does connectivity look like for those communities. So why do we care about this? Because it helps to think about how we can do modeling of demand and where people have no coverage and things like that. Because to be frank, almost all of the public information and data sets around coverage and connectivity are overly optimistic, I truly believe. So we've looked at both the population mapping as well as our own mapping of where our 2 billion users are to try to come up with statistics around what connectivity looks like in terms of coverage and things like that. And so these are some of the summaries. So roughly 80% of people today have some form of 3G or 4G coverage. That is, I think, miraculous. But at the same time, roughly 18% have no coverage whatsoever. This represents 1.4 billion people. This is obviously in some overlap with the 1.5 billion that are being discussed today, but it is, I think, a significant challenge to think about what is it going to take to do that. And then only 3% have 2G only at this point. So what we did with that is we can start to build a model of what it would take to connect all of those people, 1.4 billion people. And when I say we, I mean the sort of we of the world, of what it would take in principle to do this. So if you go down on the column on the left in terms of what is your assumption about how much data someone needs, and I heard Nicholas talk about 100 megabytes per month. We start at a larger number, but roughly at this point, somewhere between 2,000 books a month to 4 high-definition videos. That's sort of the bounding on what 2 gigabytes per month would be. And then you look at what is the adoption rate, ranging from 10% up to 100%. And if you wanted to connect all of those people, it would take something between 3.6 terabits per second to maybe 54 terabits per second. That's the range. So rather than anchor on a particular number, the point is any of these numbers are less than 1% of what global internet demand will be by 2020. It's a very, very small number. And if you factor in devices and everything that's required to consume and create content on those networks, it's still, I think, a very, very reasonable number. So I think has been discussed before, money isn't the issue. Technology isn't the issue. It only comes down to who and the will to do it. And so we wanted to share this because we believe that we wanted to use data to support the argument that this doesn't have to be a big problem to solve. This is another perspective. We looked at sub-Saharan Africa to understand where are people relative to current infrastructure. And so we segmented based on population, distance to towers, and tried to do a sort of a cumulative count of where people are within, in the example on the left, 2 kilometers from 4G, all the way up to 50 plus kilometers from 2G. And you can see that this is, to me, one of those slides that sort of points to why, in some cases, there are currently market failures in trying to connect to people on the right side. Every incremental dollar that a telecommunications company will receive, logically and rationally, should go to people on the left. It's just so much easier to connect someone who is 2 kilometers or 5 kilometers from an existing tower than it is to try to think about connecting a rural community of a few hundred people 50 plus kilometers from existing infrastructure. And while there's only 45 million people that are greater than 30 kilometers from an existing piece of infrastructure, we think it's an imperative to think about what would it take to connect those communities. And so at Facebook, we spend a lot of time thinking about what it would take, and right now we believe that what it does involve is satellite, and we're invested in our own efforts around high-altitude platforms, sort of a crazy bet to see if we can make satellites that can sort of persist in the atmosphere as well. So this is one example of that. This is an aircraft that we built. It runs on the power of about 5 blow dryers, but has the wingspan of a Boeing 737. And this is it. It's a fully autonomous aircraft that can fly itself, and this is it landing with no wheels. It has Kevlar skids on a sand patch in the Arizona desert. I wanted to show you this just as an indication of where we are in terms of the state of the technology. We have a long ways to go in terms of technology development, but we're pretty excited about the progress we've made so far. We've also worked on communication systems as well. We built a terrestrial link using a portion of spectrum called the E-band and demonstrated over 20 gigabits per second over 13 kilometers. So this is about, 1/1000th of the capacity that I talked about in previous slides. Just one link. We've since doubled that rate. And then we flew it in a plane. Ultimately, we'll go into our drone system to demonstrate 16 gigabits per second. So roughly, 1,000 aircraft circling worldwide could meet those global needs to connect all the unconnected. And I think the point here is that, with adequate amounts of access to spectrum and technology advancements, the belief is that these kinds of capabilities are imminently doable. And so with that, I just wanted to close. I think ultimately, connecting communities has to be a priority, and we want to be part of the solution with this community. So thank you.